talk about being able to divide polynomials with missing degrees. Okay, I'm going to get there in a minute, but you guys are doing really good. So this is what we did yesterday. Or no, this has a remainder. So this is what's different with from yesterday. And I think I'd like to write this. I am recording, right? I am. Good. Okay, so if I have a polynomial, right, this is a graph. Let's actually cover this up. Why am I having an issue right now? Cover this up. And let's talk about what this looks like. All right, can you guys show me what this looks like? It's to the 4th degree. Okay, I should see this. Looks like football goals, right? What else do we know? Yeah, you're right. Huh. That's exactly what I wanted. Okay, so it looks like a W. Okay, what else can we skip from this? What? It's going to go up because it's positive. We have the y-intercept at -6. That's about all I've got right now. Okay? So if that's all I've got, this is about all I can do. I don't really know anything else. I know that it's going up. That means it's got to pass because it's got to come over here, right? It could be some version of that. Okay? What I'm trying to do with this division, guys, is I'm trying to find this here. I'm trying to find this and that. That's my goal. Okay? That's why we use division. I'm trying to find zeros. I'm trying to find solutions so that I can graph it better than it's being graphed right now. So by Tuesday, we should be able to do that. You should be able to find as many zeros as you can, and you should be able to graph these as accurately as you can. Okay? Now, what this long division, this is kind of like a day of, well, guess what? I'm going to show you this one other trick, but I'm going to show you how it's not going to work over and over and over again. I know that sounds weird, but it's necessary. Okay? I'm going to show you how it's not going to work. It's kind of like working backwards for a second. Okay? So this is how I know it's not going to work. I'm going to ask myself if this is a factor of this. If this was a factor of this, I would get a 0 remainder. Okay? Let's go back to the one I had you do when you first came into class. Oops, didn't want that. I asked you to do x squared plus 7x plus 12, and I told you that one of your factors was what? X plus 3 or x plus 4? X plus 3, right? So let's piece together what we could get from this information from our graph. What do we know? What does it look like? What does the x squared tell us? It's a parabola. Good job, Tristan. It's a parabola. Do we know anything else? Good job. The y-intercept is at 12. Okay. So that's about all I know. And it does something like, I'm going to say, does something like this, because I know a little bit more than I'm letting on that I know. Okay? All right. So I'm going to put x into x squared. X into x squared goes x times. I saw in the last class they really liked this because everything's just in columns. Okay? So x goes into x squared, x times 3 is 3x. X times x is x squared. Draw the line. Change the sign. I asked myself, Philip, what do I need to multiply by x to get x squared? I need x. I put it in the x column. Just like if you were separating change into a drawer, would you put the quarters and the pennies? No. No, you wouldn't. You would put them in the quarters and the quarters and the pennies, right? So I'm going to put the x's in the x column. I'm going to put the x squareds in the x squared column. I'm going to put all of the constants in the constant column. Okay? All right. So I draw the line. I change the signs. I know I changed the signs. This goes away. I have 7x minus 3x is 4x. Brother, bring down, right? Let's do our cute little graphic. We've got Daddy, Dad, mom, sister, and sister is where we subtract. Look how cute this is. Divide, multiply, subtract. Brother is bring down. Because remember, draw the line, change the sign. And then Rover, which is repeat. Okay, so I've got 4 x's, so now I need a brother bring down. And I've got 12. So now I ask myself, how many times will x go into 4x? Or what times x makes 4x? We could say that as well, which is 4. 4 times 3 is 12. And 4 times x is 4x. Sister subtract, draw a line, change the sign. This goes away. This goes away. I get 0. Therefore, when I get 0, I know that x plus 3 is a factor. I'm going to write this differently. Check this out. This is what we are saying essentially. You ready for it? If I have a polynomial function, x squared plus 7x plus 12, if I'm solving that polynomial function, which I can see over here on my graph, right? If I want to solve that, I know that x plus 3 is a factor because when I divide x plus 3 into my full polynomial, I get x plus 4. Right? So these are, what did you say, Allison? They are the zeros. So my zeros are -3 and -4, which is what I told you. I knew a little more than I let on that I knew, and that's how I knew how to draw my picture. And the reason I know this is because the way I created the problem was I was doing rainbows and checks in my head when I created it. I said, I want my zeros to be 3, or -3 and 4. I want this to be 3 and 4, which is 12. And these two add up to 7x. I created the problem in my head by factoring in my head. Okay? So what I'm trying to say is today's problems are not going to be factors. Because when we go next, what we're going to do tomorrow is we're going to test different zeros to see if they're factors. So that's the way we're going to find out how to graph our function, is by testing different factors, dividing, and see if we come up with 0. So today's a remainder day. So are we going to find any zeros today? No, because we're going to find reminders. And when remainders tell me that it's not a factor. Okay? So we're going to do a bunch of busy work, basically, but it's like a practice day, okay, for the real thing tomorrow. So it's really important you do your homework tonight. Okay? All right. Does anybody know how you could check some of these? You could multiply. There's actually a faster way.
I don't know what I was doing yesterday, but I need to see it.
Good. You could FOIL. Wait, I think I heard it. Use the box. I still haven't heard the one that again, you guys just, it's like you don't utilize all of your power. There's something that I go to, no. Technology. Desmos.
Oh.
Desmos, if you put it in Desmos, you'll get your zeros on a graph. Okay. Desmos confuses you. Okay, let's talk about this for one quick second. Okay? And then we're going to move on. So what this problem is telling me, let's not talk about multiplication. Let's talk about a graph. And I really should be like less lazy. There we go. All right. So let me try and graph this. First of all, honestly, if I was trying to be really lazy or resourceful, these two things go hand in hand, right? I would try and factor it. Is it factorable? Let's see, 3 and 5. Are 3 and 5 going to make 3? Is there any other way to factor that? 1 and 15, is that going to give me 3? So it's not factorable. That doesn't mean it doesn't have zeros, though, right? Right? It's got to cross the x-axis because you know why? It's positive. It's a parabola because it's squared. And it's down at negative 15. I'm going to count by 5. 5, 10, 15. It's down here. I should change my color. Yes, my first x is always the shape. It's like, it's the leading. Give me a second. Okay. It's the leading term. The leading term always tells you the shape of your problem, or the shape of your polynomial. Okay, so I know I'm at negative 15. So I know I don't know if it goes right here. It's probably going over here or over here. I'm not quite, I'm just going to do this. I know it crosses the x-axis, but I know it's not integers because if it was integers, I would be able to factor that. Okay? All right, so let's see if x plus 2 is a factor. If x plus 2 is a factor, where would this cross the x-axis? Talk with your neighbor for a quick second. If x plus 2 is a factor, where is it going to cross on this graph? Oh, you guys already said it loud. Oh, I said talk to your neighbor, not shout out an answer. Okay. 5, 4, 3, 2, 1. If x plus 2 is in fact a factor, then negative 2, right? Negative 2 is going to be my 0. So it'll be right there. I'm going to pretend like I'm an Algebra 2 student at home. I'm going to be lazy, right? And I'm going to check this out and see if it is. I'm going to go in Desmos, and we're going to put in x squared plus 3x minus 15. Desmos. All right, guys, x squared plus 3x minus 15, is that what I said? Let's check it out. It crosses at, I can't even see that, negative 5.6 and 2.6. So is negative 2 a factor? It's not. It's not a factor. Okay? So that's one way of checking. All right, so let's try this. I'm going to finish it. So if I were to do it with long division, I would say x squared plus 3x minus 15 is going to be divided by x plus 2. Put my lines in. And I ask myself, x times what makes x squared? X. X times 2 is 2x. X times x is x squared. Draw my line, change the sign. Comes out to nothing. This becomes x. Brother, bring down. Negative 15. I ask myself again, x times what makes x? 1 does. 1 times 2 is 2. 1 times x is x. Draw the line. Change the sign. This goes away. I'm left with negative 17. This is how I will expect you to write it. This is what this means. I have a polynomial function, x squared plus 3x minus 15 is equal to, if I factor out x plus 2, I'm going to get x plus 1. But I know that those are not zeros of my graph because why? Because I have negative 17 left over. On your desks, go ahead and multiply that for me and see what you get. I want you to multiply this. Okay, so I could use a box method, but because this is a binomial times a binomial, I'm going to say, you know what, I could just use rainbows and checks. X times x is x squared. I should change my color. X times x is x squared. 2x and 1x makes 3x. 2 times 1 is 1. Minus 17 is equal to x squared plus 3x. This should have been a 2. How do I know I was wrong? It didn't come out the same. Plus 2 minus 17 is negative 15, and they match. Okay? All right. Okay, let's try another one. Okay, so what we're doing today, I've got one more. You guys ready for one on your own? Thumbs up, thumbs down.
One more together.
Okay, I think I'm going to jump ahead and then come back. Let's do that. Kind of like a skip stitch, right? Go over and come back, go over and come back. Okay. Okay, let's compare and contrast. Let's see. Taylor, can you tell me how to write 1003? How do I write 1003? Is that right? But why? I've got the 1 and the 3. Oh. So it's important? The zeros are important? Really? But I don't like to write zeros because that's just extra work. Okay, I think you're getting my point, right? Even though it's extra work to write the zeros, do they have importance? They're placeholders. Okay. All right, they're placeholders. I get it. So this is much different than 13. Okay. All right, Rain, can you tell me how to write this? How do I write x cubed plus 3? Let me change my color. There's an x, it's cubed. Okay. Plus sign 3. It's right until I do this. Until I want to divide. Okay? And this is why. Right? Now let's go back to the same scenario. Let's pretend I didn't have my placeholders. And I just had 13. And I tried to divide it by 3. Would that work? No. So what do you think I need over here? Placeholders. Okay, so I have an x cubed. What should come next? X squared. Do I have any x squareds? I don't have any x squareds, but I need a placeholder, just like I need a placeholder here. Right? Do I have any x's? No, but I need a placeholder because I have a placeholder here too. Now I can write my 3. Does that make sense?
Oh.
Do you see the connection? I couldn't divide. If I was going to take this, Philip, and divide it by 3, I would need my placeholders. I don't have any hundreds. I don't have any tens. You have to have, as soon as you have a 3 here, you need to have a 2, a 1, none. That's exactly how I read it to myself. So if I had 100, I'd be at 99, 98, 97. I need all my place markers. No. Okay, are we ready? Can we do this? Okay, so quiet down. All right, so this is what I say to myself every time I start to divide. Okay, Lucas, Can you please put a cap on that and pay attention for me? Thanks so much. Okay. 3, 2, oh, 2, oh, there's no 2. I better put a 2 in there. 3, 2, 1, none. Do we normally put zeros in front of our numbers? We don't. You could do. Oh, I could do that all day long. You go ahead. How many times does 3 here? How many times does 3 go into 0? 0. 0 times 3 is 0. Draw the line, change the sign, bring down. How many times does 3 go? You can do that all day long if you want to, right? Okay. So tell you what to do. Is that what you said? All right, let's do it. All right, so I'm going to make sure I have my placeholders in. So when I write down my dividend, I'm going to write 15x cubed plus 0x squared where is it? There it is. Plus 8x's minus 12, and I'm going to double check. 3, 2, 1, none. 3x squared plus 6x plus 1. Do I need to move somebody? Is that why I hear talking right now? Remember I told you. Okay, this is really important. You also need to make sure that these are all represented as well. So if this wasn't here, I would need a 0x there. Okay? You got to have all your places. Okay, so I'm going to do this really quickly, and then we're going to do one on your own. Okay? All right, so I'm going to start with my 3x squared, and that is going to be divided into my 15x cubed. 3 times what makes 15? 5. 5. Okay, what about my x's? X times what makes x cubed? X, right? So that means I better go into my x section, and I need a, hold on. I'm glad you guys are all like, wait a second, you passed something. Does it make sense? Because, well, I'm going to show you right now. Don't think about it until you start just ask yourself, 3 times what makes 15? 5. We already know that. X squared times what makes x cubed? X. Make sure you put it in the dimes. Nickels, pennies, nickels, dimes, quarters, right? Yeah. It goes in the x column. So I'm going to put it in the x column because it belongs there. You wouldn't put it in here. It wouldn't work. Okay. So I've got 5 x's. 5 x's times 1 is 5x. I still put it in the x column. 5x times 6x is 30x squared. I put it in the x squared column. And 5x times 3x squared is 15x cubed, and we put it in the 15x in the x cubed column. Draw the line. Change all of your signs. This goes away, and we're left with negative 30x squared plus 3x. Hold on. Let's finish it up. Bring down negative 12. Change my color. We're almost there. 3x squared goes into negative 30x squared. Okay, I ask myself, 3 times what makes 30? Negative 10, right? So I could, at this point, once you get this first one, you don't even need to even pay attention to the x's anymore because you know it's going to go right next to it. It has to. It's the next one over. So it's negative 10. Do we have any x's in this column? Nope. As soon as you know where your place marker starts, you just keep going this way. And that's it. You don't need any of these. It's just like this.